I think it's likely in the near term, at least, we're going to see meaningful divergence between the way that our AI systems work and the way biological brains work. And this is where I think there is a very fair critique of we need to have good tastes when we take inspiration from neuroscience and apply it in AI, because neuroscience, the way brains work, as magical as they are, is a process that is constrained in ways we don't need in our AI systems. For example, we perhaps have access to far more energy and we're willing to be way less energy efficient. So that means that the parts of the brain that are optimized for energy efficiency, perhaps, at least in the near term, don't matter to us. It's not worth the tireless effort to try and figure out how brains do that. Brains also have huge evolutionary constraints. So it's very likely that's not an optimal design. Versus when we implement things in silicon, maybe we can find an optimal design, throw away a previous design from scratch. So I think it's likely that we're going to end up with AI systems that work in very different ways because they don't have the same constraints that brains do. And so the question, which I have thoughts on, is what are the aspects of how brains work that are relevant, which is not obvious. The goal is clearly not to recreate the human brain wholesale, but what exists in the neuroscience of what we know about brains or don't yet know that we think will be useful and practically relevant to building smart AI systems? That's the hard question.